in fact, for error research, regardless of whether the data is time series or cross-sectional or panel data, the first step we tend to conduct summary statistics. Okay, in fact, we have learned summary statistics in a lot of modules, in particular in econometrics 1. So, how can we conduct the summary statistics in PCQ? In fact, it's also quite straightforward, right? Ensure that I just take the log of the time series as well as the log. For summary statistics, you should use a category model for other models, model plus descriptive statistics. And you add the time series you want to test, okay? For example, in this case, the natural log of this, in fact, this is US Deutschmark exchange rate. So we add the natural log of Deutschmark as an example, right? In fact, in summary statistics, you tend to report mean and standard deviation, right? Please find a chair and share it with others. I just show some operations. So at least you should show means and standard deviation. So the first option here is means and standard deviation, right? You can do it. And here, the software report means as well as standard deviation, right? It also shows the correlation matrix between variables. Since we only add one variable, so there's only show one variables. If you add, for example, if you have 6 variables, you can add it in this correlation matrix. It will show the relations between different variables, right? In fact, the second option is about normality test and descriptive statistics. Okay, it also shows the mean and standard deviation, exactly. Show you example. Okay, show you example. And in this test, you get the number of the observation, the mean, standard deviation, skewness, kurtosis, etc. Sometimes in summary statistics, you may want to report mean and max value. It also shows mean and max. Okay, it's quite straightforward. It's about summary statistics. In fact, for the time series, I think one of the most important steps is about unit root test. Okay, how can we conduct a unit root test in the PCQ? There's a unit root test. Okay, we use an augmented Dickey-Fuller test. Okay, augmented Dickey-Fuller. If you want to follow Parris procedure, it would be better. Okay. However, I should say, in lecture, our professor never mentioned about the Parris procedure. I just mentioned procedure in seminar. So, in other words, it is not required. Also, you know, in some assignment, the second question only accounts for 10% of the overall score. So, you can make a decision whether you want to follow the Parris procedure. Okay, but later I will show you both. Okay, so what is Dickey-Fuller test? Okay, initially, this is AR1 process. In the AR1, if beta equal to 1, it's a random walk. So how can we check whether beta equal to 1? For both left-hand side and right-hand side, we minus YT minus 1, right? By parameterizing, we get this function. We call this Dickey-Fuller test. This is a Dickey-Fuller test. Dickey-Fuller test is adequate if the residue is subject to ID process. However, if residue have autocorrelation, we should control for this autocorrelation. So we introduce augmented Dickey-Fuller test. Okay, this is a ADF test. Okay, but in the ADF test, you should also know every time we check the coefficient phi, whether the coefficient phi is significantly different from 0. Okay, if the coefficient phi here is significantly different from 0, we know in the AR1 process the beta should be significantly different from 1. In other words, it was not a random walk. So, but I also want to emphasize here is that for the ADF test can help you to identify whether the time series exists unit root, but how many unit roots? In other words, what is the order of integration of this time series? We don't know, okay? But how can we identify? For example, if your initial time series based on the unit root test, you know is a non-stationary, you can conclude that there exists a unit root, but how many? You should also take the first difference. If the first difference is stationary, you can conclude it's an I1 process. If it was a non-stationary, you should also test the second difference. Okay? If the second difference is stationary, you can conclude it's an I2 process. Okay? Because ID stands for different d times to get the stationary process. So in the TCD, also the category other models, model class, descriptive statistics, and we formulate. So we know most of the time series they are I1 process, so we add both initial time series as well as the first difference. In this case, is a natural log of Deutsch-Mark exchange rate and the d log of the dm, right? So we add both. And select unit root test, right? How can we adjust for the lag length of for difference? We can identify it based on the frequency of data. Since you use monthly data, so we can use 12. Okay, lag length should be 12, right? And finally, you get a result. You get a result of 13 specification. Okay, 12 equation of ADF test, 1 Dickey-Fuller test, right? However, you can use AIC to identify the optimal order, optimal specification, right? In this case, these two specifications have lowest AIC, okay? So these two specifications are optimal specification. However, regardless of which specification is optimal, all of the specification show insignificant results, suggest a non-stationary process, right? However, for the first difference, all the results show significant coefficient of phi, right? So it suggests stationary. So the first difference stationary, initial time series non-stationary, we can conclude it's I1 process. Okay, this is about second question. But some of you want to follow parent procedure. If you want to follow parent procedure, in some of the steps of the parent procedure, ask for joint test. However, after the ADF test by using PCD, the test function does not appear. Okay. In other words, if you want to follow parent procedure, you should construct the model yourself. Okay. Just show you example. If you want to follow parent procedure, you should construct the model yourself. Category should model for time series. Model class should be single equation dynamic modeling. Okay, you formulate. We just take the test, ADF test of initial time series as an example. Okay, in other words, the natural log of the time series as an example. What should be the dependent variable in the ADF? The first difference, right? Dependent variable should delta YT. So we add it as a dependent variable. So if in the ADF you want to include 12 lags, how can you do this? Here we can include 12. And here we get a dependent variable. And for the independent variable, we add 12 lag terms of delta yt. Okay, what is a key independent variable? It should be lag value of yt, right? Yt minus 1. Okay, so lag length should be 1. So we add yt minus 1 as a key independent. Okay, here we add yt minus 1. In some situation, you also want to add a trend, so select trend and add it. Okay, we also add a trend in the ADF. This is a specification for the ADF. The dependent variable, the first difference, delta yt. Okay, the independent variable include the constant, trend, and 12 lag terms of dependent variable delta yt. And the most important part is yt minus 1. Okay, most important part is yt minus 1. And we use OLS to estimate the result. And here you get the result. Okay, here you get the result. For example, if you want to take the joint test of these two coefficients, how can we do this? Use test function. Okay. In fact, you can use wall test. In other words, f test, the joint test to test whether these two coefficients jointly equal to 0. You can check the notes of candidate trace show the wall test. Okay. Just use for the wall test. Just use the exclusion restriction function. Okay. If you want to test whether these two coefficients jointly equal to 0, select the two coefficients. And finally, you get the result. Result is significant. It means it can reject the null hypothesis of these two variables jointly equal to 0. In other words, these two variables are not jointly equal to 0, right? This is how can we conduct a joint test by following the Parris procedure. Okay, so you should make the decision because you have 6 variables, and the summative assignment asks you to conduct a unit test for the 6 variables. So if you think the Parris procedure is too complex, what's the question?
Variables, you mean the time series, right? But isn't it WS7? We have the CPI and the exchange rates. The countries are not set.
Yeah, if you have 7 time series, it doesn't matter. Okay, I don't know how many. Just show the example. If you have several time series, you should conduct a unit root test for all of them. Okay, the question asks you to conduct a unit root test for all of them. If you think the Parris procedure is too complex, you can just by using the unit test provided by PCGIF. Okay, because in the lecture our professor never mentioned the Parris procedure. Okay. So you should make a decision on yourself, okay? And also you know that question only accounts for 10% of the questions. So if you think construct the AEF yourself is easy, the better way is follow Parris procedure. But if you just use a unit root by PCGIF, it's all right, right? I think I clearly explained this question. And next question is about the PPP test, right? Please give me a space. Next question is about the PPP test. What is a PPP hypothesis? Purchasing power parity, okay? If we interpret it in algebra, it should be spot exchange rate equal to domestic price divided by foreign price, okay? How can we test it? In fact, check your notes of Computer Lab 2. It shows very detailed information of PPP test. In fact, for this question, you can use angle grinder. In fact, you can use angle grinder. But for the angle grinder test, the first step, you should calculate the ratio of P, domestic price divided by foreign price P, divided by P star. Initially, you should calculate this ratio and test whether spot exchange rate equal to this ratio by angle grandeur procedure. Okay, there have the two variables. You can take the angle grandeur, but a better way to test the PPP is Johansson approach. Okay, why? Because after you take the natural log of this equation, it's equal to this function. Okay, it's equal to this function, log spot exchange rate equal to log domestic price minus log foreign price. Okay, now you have 3 time series. Okay, you have 3 time series. How can you test the co-integration relationship between 3 variables? Johansson test. Okay, so this question just asks you to conduct the Johansson test. Okay, the co-integration test by using Johansson approach. Okay, we know the Johansson is a var-based test. Okay, it's a var-based test, vector autoregressive based test. Okay, for the Johansson test in the VECM model. In the VECM model, the most important part is a co-integrating space. Okay, the coefficient matrix pi, right? For the coefficient matrix pi, the co-integrating space, we have 3 situations. Okay, the first situation, the rank of the matrix pi. Okay, the rank of the matrix pi equal to 0. The first situation, rank of the matrix coefficient matrix pi equal to 0. There's no co-integrating vector. All the variable yt, they are non-stationary and no co-integrating vector. Okay. In the second situation, if the rank, in fact, the coefficient pi is G multiplied by G matrix. In the second situation, the rank of matrix equal to full rank. If it was a full rank, all the yt is a stationary process. If you have 3 stationary yt, it means initially they are stationary. There's also no co-integrating relationship. Okay, there's also no co-integrating relationship. The third situation is interesting because the rank of matrix bigger than 0 but smaller than full rank. Bigger than 0, smaller than full rank. In this case, we have co-integrating vectors. But how many co-integrating vectors? In fact, the number of co-integrating vectors equal to the rank of the matrix. Okay. In this case, if the rank of the matrix bigger than 0 but smaller than full rank, the rank of the matrix equal to the number of co-integrating vectors. Okay. So the question is, how can we identify the rank of the matrix? We introduce 2 statistics, lambda trace and lambda max. Okay, lambda trace and lambda max. In fact, the default setting of PCB only show lambda trace. In fact, in the second computer lab, I show you how can we get the lambda max. Okay, but in some situation, lambda trace and lambda max may result in different results. Okay, lambda trace and lambda max may lead to different results. So most recent papers tend to just use the lambda trace. So in your assembly assignment, you can just use a lambda trace. Okay, use a lambda trace to identify the order of the identify the rank of the co-integrating space pi. Right? You can use a lambda trace, and after this step, if you find the rank of the matrix is not full rank, not the matrix of 0, you can conclude you have co-integrating vector. And final step, you use a PCB, construct a co-integrating var. Okay, in the co-integrating var, the software show the co-integrating space. This co-integrating space can be defined by the production of the 2 matrices coefficient matrix alpha multiplied by the transpose matrix beta, okay? We call the alpha matrix of speed of adjustment. The transpose matrix beta is a matrix of co-integrating vector, okay? The transpose matrix beta show the matrix of co-integrating vectors, okay? The co-integrating vectors, in fact, show you the relationship between the three time series, okay? In other words, just use the co-integrating vectors. It shows the relations between the three time series, spot exchange rate and domestic price and foreign price, okay? For this question, you can just follow the notes of Computer Lab 2, okay? Follow it step by step. It shows very detailed information. I will not repeat it because the time is quite limited. The next question. Next question, in fact, is about ARMA modeling. When you construct ARMA model or Gauch model, you should remember when you predict the future value, you should always put the stationary process as a dependent variable, okay? We only make a focusing based on the stationary process. If it was a non-stationary, we can't construct a model based on a non-stationary process, okay? So that's the reason why the second question is so important, okay? So you should identify whether time series stationary or non-stationary and construct the model only based on stationary process. So for the ARMA modeling, we follow the Box-Jenkins methodology. In fact, it's three-step process, okay? The first step, identification. How can we identify the order of ARMA? We use ACF, PACF, right? ACF, PACF. The second step, estimation. How can we estimate the coefficient of the ARMA? We use a maximum likelihood, okay? Or least square, okay? For example, ordinary least square. But in PSGIF, we tend to use maximum likelihood, okay? That's the second step, estimation. The third step, model checking, okay? Model checking. How can we check whether the model is adequate? We have two techniques, overfitting. As well as a Young-Box test, in the receiver-based test, Young-Box test, or in other words, Q statistics. Okay? But how, for the overfitting, some students asked, how can we conduct overfitting? For example, you construct, if your ACF and PACF suggest AR1 model, you test this AR1, okay? You get a significant coefficient of the YT minus 1, okay? And then you overfit. In other words, you try AR2 model, okay? You try AR2. If in the AR2 model, the AR2 component, YT minus 2, is significant, the AR1 is not adequate. You should use AR2. If the AR2, in the AR2 model, the AR2 component, YT minus 2, have insignificant coefficient, your AR1 model is adequate. Understand? So your initial model is only adequate if your overfit model have insignificant coefficient, okay? And also, for each of the model, you should take the Young-Box test to check whether the residual is the IID process. I'm going to show you, okay? Initially, we should plot the ACF and the PACF, okay? because ACF, PCF of both initial time series as well as first difference. We create separate plots, but we create both ACF and PACF. And based on the first plot, it just suggests random walk, right? It's a non-stationary, okay? Because ACF does not decline, okay? If you think it looks like A1, I should say the coefficient equal to 1 is also a random walk, okay? The second plot is a plot for the first difference. The time series becomes stationary, okay? But do you think it shows any very clearly pattern of AMA? In fact, I upload the document name guides for ACF, PSF plots. I don't think it shows any very clear pattern of AMA. However, we'll check it to find it is also not a white noise, okay? The first leg, in the first leg, the ACF, PSF significant, second insignificant, the third significant, the fourth also significant, the fifth insignificant. So in this case, I suggest you can try from AR1 and overfit one by one, okay? Overfit AR2, AR3, and at least until the AR4, because in the first leg terms, there's also it seems a significant result. So you can try from AR1, but in this case, I show you. I just try AR4, okay? But when you conduct research, you should overfit one by one. I just show you an example, right? I construct the AR4 model. The AR4 model, so the AR order should be 4, right? The ML order should be 0, and the fractional parameter D should fix at 0, okay? When you construct the AMA model, you should fix this integration, fractionally integration parameter D at 0, okay? In other words, we exclude the integration part. This step also important, pay attention, okay? We use maximum likelihood to estimate the result. And here, we get the result, okay? When you check it, we find AR1 component significant, AR3 significant, AR4 also significant, but AR2 component insignificant, okay? So you want to check whether we can exclude this AR2 component, okay? How can we check whether we can exclude this AR2 component? We can also conduct the word test, okay? Word test is showing your nodes of computer lab 3, okay? We just use the test function, exclusion restriction, right? Exclusion restriction. If we want to check whether we can exclude the AR2 component, we can select AR2, okay? If we want to check whether, in fact, the constant is also insignificant, if you want to test whether these two components jointly equal to 0, you can choose the two at the same time. And then you get a result. What does the insignificant result mean? In fact, the null hypothesis, they are jointly equal to 0. It can't reject jointly equal to 0. It means they are jointly equal to 0. So we can exclude them from the model, okay? So, for example, if you want to exclude the AR2, how can you do this? Just repeat the model, okay? Repeat the model. If you want to exclude the constant, you can just remove the constant, okay? Just remove the constant. But how about the component of the AR component? For example, if you want to construct the AR4 model but exclude the AR2 component, you should fix AR lags at 2, okay? You should fix AR lags at 2. The model will exclude it, okay? And finally, we get a result, okay? We get a result. This is an AR4 model, but there's no AR2 component. There's also no